Today we're verifying identities again. This is the 6th day. Today we're going to introduce graphs into the whole concept of verifying identities. So for this example, you're going to notice that the information presented to you is different. So they're going to give you a picture. So here is the picture that's going to be given to you. So notice this is a cosine wave with an amplitude of 1, and one wave is completed at 2 pi. And then the other piece of information given to you is secant of x plus tangent of x. And this is going to be multiplied by secant of x minus tangent of x. That should all be on the same line, it's just I ran out of room on my screen. And it's all divided by secant of x. So I want you to notice what's missing in this identity is I don't know what I'm trying to prove that the identity is equal to. But what they did give you is a picture. And we need to use this picture to figure out what to set this identity equal to. So based on this picture, I definitely know it's a cosine wave. I know the amplitude is 1, so I can determine that my A value is 1. It's starting at 0, so my C value is definitely going to be 0. And the wave is completed at 2 pi, so I know that the period is equal to 2 pi. So I need to figure out what my B value would be. And remember, we find period by doing 2 pi divided by B. So if the period is equal to 2 pi, that means my B value would have to be equal to 1. So based on all of this, we've determined that this wave is equal to a 1 cosine of x. So A is 1, B is 1, and C is 0. So now we can say that this whole identity is going to get set equal to cosine of x. So now I know what I need to prove this to be equal to. I'm going to switch screens so I have some more room to work. So I'm taking this secant of x plus tangent of x times secant of x minus tangent of x all over secant, and I'm trying to prove that it's equal to cosine. So again, the only new part is now you have to figure out what you're setting it equal to. So to kind of verify, we're going to work with the left-hand side, and in the numerator, I have these two binomials, so I'm going to FOIL them. So that means I am distributing secant to both of them, and I'm going to distribute tangent to both of them. For those of you who do the box method, this would be the box method, and you'd fill it on the outside. So secant times secant would give me secant squared of x. Secant times a negative tangent will give me secant of x tangent of x. And when I do my inner, I'll get a positive tangent x secant x. And then my last term will be minus a tangent squared of x. And this is all over secant. And I can determine that these two terms right here in the middle are going to be able to be canceled because multiplication is commutative. So the order of this doesn't really matter. So I have a positive secant tangent and I have a negative secant tangent. So they're going to cancel. So now I'm at secant squared of x minus tangent squared of x. And I need to, essentially, I'm trying to prove that this is equal to cosine. So let me just move this over real quick. So I would want to keep the secant because I know secant is equal to 1 over cosine. But what I would definitely want to get rid of is this tangent right here. And using our Pythagorean identities, I can replace that with secant squared minus 1. So the first secant squared of x will stay, and I can replace tangent with secant squared of x minus 1. And now I'm going to distribute this negative sign in. And when I do that, let me just go up here. I'll have secant squared of x minus a secant squared of x and plus 1 all over secant. And in the numerator, notice I have a secant squared minus a secant squared. So they're going to be able to cancel out. So these are now gone. And I'm left with 1 in the numerator. And I have 1 over secant, and I know that 1 over secant is equal to cosine of x. So I have now verified the identity. So we're going to do one more example where, again, I give you the picture and then we verify it. It's not as long as this problem. So here, our picture. So the picture that is given will look like this. So I have an amplitude of a 2 and a negative 2. Again, the distance for the one wave to be completed will be 2 pi. So there's the picture that's given to you, and the identity that we're trying to prove is cosine of x plus cotangent x sine of x all over cotangent x. And again, I need to figure out what I want to set this equal to. So I need to work with the wave and figure out what kind of wave this is. So I definitely know that this is a sine wave. I also know the amplitude. So my A value is a positive 2. Again, I'm starting at a value of 0. So I know my starting point would have to be, for C over B, I'd have to get 0, so C is 0. And it ends at a 2 pi. And again, when I do period divided by B, 2 pi over B, B would have to be equal to 1 in order to get an answer of 2 pi for the period. So I know that this has to be equal to 2 sine of x. And now that I figured that out, this is what I have to set this identity equal to. And again, I'm going to go to the next screen so I have more room. But this identity, we're trying to prove that it's equal to 2 secant, or 2 sine of x. So I have cosine of x plus cotangent x sine of x all over cotangent x. And I'm trying to prove that this is equal to 2 sine of x. So in the numerator, as far as strategies go, I can't factor anything out. I can't FOIL. So I'm going to go back to the basics and get everything in terms of sine and cosine. So cosine of x is already good. That's in terms of sine and cosine. I can change cotangent to be cosine of x over sine of x. And I'm timesing this by a sine of x. And this is technically a sine of x over 1. And in the denominator, cotangent again is cosine of x over sine of x. In the numerator, when I multiply these two fractions together, my sine is actually going to cancel out, and I'm just going to be left with cosine of x. And technically, cosine of x plus a cosine of x is going to be able to be equal to 2 cosine of x. So in the numerator, we're going to get 2 cosine of x, and this is still divided by cosine over sine. And now I'm at that point where I have a fraction divided by a fraction, so I'm going to keep change flip. So I'm going to keep my 2 cosine of x, and I'm multiplying by the reciprocal of sine of x over cosine of x. And technically this is over 1. And when I multiply this together, notice that the cosines are going to cancel because one's top, one's bottom. And I'm left with 2 sine of x. And this is equal to 2 sine of x, which is what I was trying to prove. Okay, so that's all for today. We'll do some more practice on this tomorrow.